Hi everyone, and I'm Jay, and welcome back to channel. We are continuing our top 100 C# interview question series, and today we are going to talk about one of the very important topic, polymorphism. So, what exactly is polymorphism? The word itself gives us a huge clue. Polymorphism. It is made from two words. Poly means many, and morph means form. So in C sharp, polymorphism literally means many forms. In other words, in terms of the object oriented programming, it means the ability of an object to take on many forms, or more accurately, the ability to treat objects of different classes as objects of a common type. Let's try to understand the concept of polymorphism with this image. The person on the right hand side is calling a method animal.speak. So this represents a generic or general command like asking any animal to speak. On the left hand side, there are different animal objects. So dog responds with woof woof, the cat responds with meow meow, and rooster responds with cocky doddle doo. Even though the same method speak is called on each animal, the output is different on the actual object. So once again, polymorphism, the way we defined it, one method, many forms. The ability of an object to take on many forms. That is what the polymorphism is. So right away we will, dive into the code and we will try to understand with the help of, the looking the code as well. So let me quickly show a basic, the example of the polymorphism. So we will start with pretty the simple, the same code, the image which we saw. We have an animal class which is having a generic implementation. Then we have three these the derived classes, the same thing which we saw in the image. We have a dog, cat, and rooster, and if you take a look, all these three objects, it's having its own implementation. Now when we are creating a collection of objects which is having dog, cat, and rooster and calling the same speak method, all these objects are behaving differently. That's exactly what the polymorphism is. Okay, so let's try to understand what are the different types of polymorphism, how you achieve it. So mainly there are the two types of the polymorphism: compile time polymorphism and runtime polymorphism. Compile time polymorphism is also known as static polymorphism. The reason being that at the time of the compilation itself, compiler knows that which method to call, right? How to resolve it. In terms of the runtime polymorphism, it is also called dynamic because at compile time, the method, it will not able to resolve that which method to call, right? It normally gets done at the time of the runtime. So that is why it's called compile versus the runtime. Now again, let's take a look the real the code to understand. So let's start with compile time polymorphism. We have a simple calculator class, and then we have three methods with the same name, add. In the first one, we have two arguments, return type integer. In second method, instead of two arguments, the parameters, we have the three. And then the third one, we have two parameter, but the data type is different. Now let's see how we are calling it. So we created an object here, and then we are calling the same add method, but the different values. So in this add, we are passing 5 and 10. In second one, we are passing the 3 parameters, and then here we are passing the double. So that is so if you take a look, the interesting thing is, right, all the in all the three methods call, right, we are calling the same method because it's add, right? But depending on the parameters, compiler already knows that which method to call. So for example, in this case 5 and 10, these are the two, the two whole numbers 5 and 10. It will be able to resolve and it will be able to call this one. In this case 3 parameters, it will be able to resolve and it will be able to call this one, and same applies for this one. It will be able to identify that, hey, the parameter is double, so it has to call this one. So this is the polymorphism through the compile time, through the method overloading. It is called method overloading, where you define the same method with the same name and then your signature is different. So it is called the compile time polymorphism or static polymorphism, which you achieve through the method overloading. Now let's take a look the more powerful, actually, the polymorphism forms which you achieve through the runtime polymorphism, and it is also called, the method overriding as well, because you achieve through the method overriding. So just to give a little bit, the definition or how you achieve is, method overriding occurs when a derived class provides its own implementation of a method that is already defined in its base class. So for this to work, the base class method must be marked with, the virtual keyword, and in derived class it must be marked with the override keywords. So whenever anybody talks about method overriding, keep these two keywords always close to your mind, that it is virtual and override. With the help of these two keywords, method overriding gets achieved. Now let's take a look the example right away. So we have one bank account which is going to work as a base class or parent class, and it is having, the two one two actually the three methods. So it has got deposit method, which is having its own generic implementation. Then we have the withdraw method, and then we have the display balance. So pretty simple, the class which is responsible to, handle the deposit, withdraw, and the showing the balance. Then we have one, the derived class saving account, and then it has got its deposit method, its own. So what actually it means, that it has got its own implementation. The same applies for the withdraw as well. It has got its own implementation, and the logic own implementation means that it has got a little bit different implementation than the generic one. Okay, so I'm not going to in detail that, in detail about the logic what is different, but mainly, I mean, think about it, that it is a saving account, so you got bonus on this. When you are doing the withdraw, there are some, the check and balances that, you should have sufficient fund to get, to perform the withdrawal. And then apply interest. I mean, you can also apply the interest. Now checking account, which is another derived class, and it has got, its own implementation of the withdraw. It's not having the other, the two methods deposit. It's not having deposit implementation for the checking account. Now the main thing, let's try to understand here, which is interesting, right? So we created the, one object of the base class, then we created object of saving and checking, and see that how the polymorphic behavior is being achieved here. So here we call the generic account, right? So generic account deposit gets called. Obviously what actually it is going to do, it is going to call the base class deposit method. Then my savings dot deposit. So my saving, which is a derived class, and it is actually overriding the deposit method. If we take a look, in base class we have a virtual and deposit, and then in saving account as well we have override. So what actually it means, that it is overriding the deposit method. So whenever you are going to call the saving account object and deposit method, this implementation is going to be called. So this is how polymorphic behavior is getting applied here. So saving account deposit is going to be called here. The same thing, the saving account withdraw, okay, and checking here, excuse me. Now let's see this example, right? How it is being invoked. So we created a list, the collection of bank accounts, and then we added these, the five objects. When I say five objects, what I mean that we added one generic account, one saving account, one checking account, another saving accounts, and another checking account. So there are the total five objects within this list collection. And then we are calling these methods within the loop. So see, quite interesting, right? So when display balance is being called, no derived class is having its own implementation. So what actually it means that it is going to call the base class or display balance, but here the account or deposit, right? Deposit is having different implementation. Saving account is having the implementation of deposit, but checking account is not having deposit implementation. So what actually it means that when saving account is going to call this one, it is going to call the saving account deposit implementation, that method, but for checking it's going to use the base one. In other words, I mean, it is a generic implementation for any other classes which is not having the deposit methods tagged with the override, and same applies for the withdraw. So in our example, both are having withdraw, whether it's a checking account or whether it's a saving account, and therefore it's going to call its own implementation. So see how powerful the polymorphism is, that you are able to change the behavior at runtime. Okay, so now let's move on. How you can achieve polymorphism? There are different ways to do that, right? I mean, mainly, I mean, we so far, I mean, we touch base method overloading, and we touch base, the method overriding. But apart from that, right, I mean, there are the different other ways as well you can achieve the polymorphism. So operator overloading is another one, where again it is a compile time and you can achieve polymorphism in web API, as well as uh, enterprise level application. Normally you don't use operator overloading a lot, but in case if you're going to work like the aesthetics classes, some maths like vertex and all those things, right? So that is where the operator overloading people use it. Abstract class, again, I mean, it can have abstract as well as non-abstract methods, and then wherever you have those the abstract methods, I mean, you can use the override, and then you can achieve the polymorphism. That is, again, I mean, since it is the override, I mean, it is a runtime. Interface implementation, that is another way you can achieve polymorphism. So in interface implementation, the way you do that, you define the interface, you define the contract there, and then all the derived classes which implement those interfaces, they have their own implementation. So that is another way polymorphism gets achieved. And then delegates, lambdas, as well as the generics, I mean, those are some the different ways you implement the polymorphism. Now let's touch base quickly some the tips in case, I mean, you are in interview and your interviewer is talking about the polymorphism. So one thing is that define polymorphism clearly. And when I say define polymorphism clearly, what actually it means that mention the both types, the compile time, runtime, mention overloading as well as overriding, explain that what are the main keywords: virtual, override, abstract, right? I mean, these are the mainly three keywords you use it in order to implement the polymorphism. Discuss the benefits. I mean, what is the whole idea behind the polymorphism, why people use it? The simple answer is that reusability as well as the flexibility, right? Also mention the interfaces as well, that you can use the polymorphism through interfaces as well. And it is pretty the typical and interesting question many times interview ask, that can you achieve polymorphism without inheritance? Yes, interface is the way. That is how you can achieve the polymorphism. So, all right, that was all about the polymorphism today. We covered, I mean, the definition of polymorphism, we talked about importance, we talked about the compile time polymorphism, method overloading, runtime polymorphism with method overriding. We also covered the virtual override keywords. We also touch base that what are the different ways you can implement polymorphism. So that's all for the today. If you like this video, this episode, please do subscribe, like and comment, and thanks for the watching.